Sorry, I have to get into my Obama. It's not great today. I'm not feeling it, you know. We'll get there. Howdy, howdy. Welcome, welcome. We are just getting started. I will start answering questions in just a moment. I'm just getting the live chat set up, and then we should be good to go. All right, I think that we're all set to go, so you guys know what to do. Feel free to ask questions, and I'll do my best to answer them. Keep in mind, I don't know everything, but I know a lot of things, at least about this topic. So, you know. Do you know if physics degrees are general accepted from Germany? Yeah, like if you have a degree and you can prove it, like it'll count anywhere in the world as long, but you know, the quality of the degree does matter. Can you talk about electrostatics? What about it? So, I mean, it's true that, my green screen's really not good today. So electrostatics is just the behavior of charged particles in the presence of a non-changing electric field. That's all. Why would you want a matrix to be Hermitian? So you can do quantum mechanics. Duh. Random uneducated thought. Do photons lose energy when redshifted, and could that add to expansion? So they do lose energy when redshifted. They do not add that energy to expansion. Where did I do my PhD? I'm not telling you. I'm just not going to tell you. Do you think commonly misunderstood terms in science, spin, theory, observer, etc., should be changed to reduce confusion? These are not things that can be changed. Like you can't. That would be like, what's a good analogy? Like there's not like a central committee that could like decide to change that, because like people learn from different texts, but like it's just not a thing that's possible. It's only quantum events, not every actuality. What would happen if an asteroid would hit a nuclear reactor? Probably you would have horrible nuclear fallout. Like horrible nuclear fallout. That would be my guess anyway. Tips for electricity and magnetism physics too. Get good at integral calculus. Can you build a ray gun? Funny story, when I was an undergrad, I actually entered into a competition where we were designing a handheld laser. And the design I chose was an old school style phaser from Star Trek, and I shoved a huge ass red laser in there, like 3 watts, but I didn't win. Do you know how to do ciphers? It's not something that I've ever spent time working on, no. Is number theory at all relevant to physics? Rarely, but sometimes yes. It shows up, like number theory facts and number theory like applications show up in like very specific cases when you're doing some very specific quantum mechanics usually. Sometimes string theory too. What do you think of the new small core nuclear reactor concepts? I'm not familiar with them, but they sound good, if they're as they sound. By the way, remember to like the live, whether you're watching on YouTube or on TikTok. It helps get more people in here so we can get better questions. What's your programming language of choice? I mean, I just use Python when I have to, but I don't do that often. What do you mean by observer? Can you clarify? Yeah, so when we talk about an observer in quantum mechanics, all this means is an instrument that's macroscopic and can make a measurement. Do you have any recommendations for textbooks on modeling complex systems or systems with no analytical solutions? I don't, because that's not something I've ever done, and I never took any courses on it. So unfortunately, I don't have any that I can recommend on in that regard. Would the smallest period of electromagnetic waves be related to the Planck length, maybe 2 times that? Yeah, sort of. At least that's the smallest period where we expect to not have gravitational effects. Talk about the Higgs field. I'm not quite clear what you want me to, but what you want me to say. But essentially, the Higgs field is the fundamental field that gives rise to mass in the other fundamental particles. And one of the analogies that's often used is kind of like molasses. You have some particles that get slowed down through the molasses, and that's like them effectively gaining mass. Favorite undergrad course? I took general relativity as an undergrad, and I love that, which is why I'm doing what I'm doing. What's the difference between mathematical and theoretical physicists? Theoretical physicists are closer to physicists than mathematical physicists are. Mathematical physicists are in some regard perhaps closer to mathematicians. It's based, so mathematical physicists often prove things, like rigorously using mathematics. Theoretical physicists don't do that as often. Can we all agree to stop treating black holes like these fantastical, mystical things? Well, they are fantastical, but they're not mystical. Like, they are like amazingly complicated and weird and wonderful. Are you familiar with Tim Maudlin? I'm not. What do you think about the new deep search in OpenAI and how it will affect physics? I don't know anything about it, so I can't comment. What do you do for work? What do you do for a job? I work at a university. My day job is essentially doing academic research. So I spend time writing papers, doing calculations, reviewing papers and reading papers, as that's part of the service that you do. Today I spent time working on a proof on product manifolds. Can a very precise atomic clock help us measure time dilation more precisely? Yeah, we do that. We can measure time dilation very, very precisely. Do you think there are more human-like beings in the universe? They're probably not very human-like. If an asteroid destroys the Earth, will life return to Earth after some time? Well, not if it's fully destroyed, right? What are your thoughts on Bohmian mechanics? I mean, I'm not like against it, but it just seems less likely to be true for me. Because, you know, there's an extra equation that, you know, it's less theoretically virtuous. Can you explain time dilation as you get closer to a black hole? Yeah, so what's happening near a black hole is that when we talk about gravitational time dilation, what we're really saying is that the gravitational field is different at different locations in space-time. And so if you have two different people, one near a black hole and one far away, their clocks will tick at different rates. And if they come back and meet up later, different amounts of time will have passed. Do schools really teach about the wrong atom model? It's not wrong. It's just not, like, it's not the full story, right? We always teach wrong things. It just gets less wrong every time. How do magnets even work? As in, what is a magnetic field made of? And how does it do whatever it's made of travel to? So magnetic fields aren't made of like some substance, right? Magnetic fields are essentially a way that the electromagnetic field can be. The electromagnetic field, it depends on what your ontology of the universe is, but the electromagnetic field seems to be a fundamental property of space-time. There is this thing in it. So you have position, moment, you have like X, Y, Z, T, and then you also have on top of that extra information at every point in time. And that extra information tells you about what the electric and magnetic fields are. That's what we call them anyway, those extra pieces of information. And so it's not like made of stuff. It is like, as far as we can tell, it's fundamental. It's like there's nothing that it's made of, it's just there. Which is not satisfying, I know. Are you happy? Generally, yeah. How to be a researcher at university and not be a teacher? Well, I'm a postdoc. And in my postdoc position, it's just a research position, not a teaching position. But if and when I get another postdoc, it will likely be a teaching position as well. Do you have any hobbies that are not really science related? Yeah, I've been playing Marvel Rivals a lot, and that's a good time. Who has more flat earthers, the Democrats or the Republicans? Easily the Republicans. Is the universe more likely to be finite or infinite? That's a hard question, because we don't have all the details. Currently, our universe is consistent with either. We don't really know. I lean towards it being infinite because that's simpler. It has fewer parameters to describe it. But what even is a magnet? How's it made? I do have a video on that, George, on TikTok. I don't know if it's yet on YouTube. But essentially, a magnet is all it is it's a trillion tiny electromagnets made by single atoms. So single atoms are basically electromagnets. They have electric charges just moving around, and that generates a magnetic field. And so a permanent magnet is just a bunch of those. Can you explain why quantum entanglement can't just be hidden variables? Yeah, so if you think it's just hidden variables, then you can come up with what the correlations should be between measurements. So there's this thing called a Bell inequality. Essentially, if one person measures in the up-down orientation, and then the other person measures at some random orientation, not determined until after the measurement, then you expect that there'd be a certain degree of correlation that depends on the angle. But what you find is that correlation is actually bigger than what you would have expected if there were local hidden variables. This is why the Nobel Prize was awarded to these quantum mechanics people in 2022. What rank are you in Marvel Rivals? So I just started ranked like 2 or 3 days ago, and I've only played like 8 games. I think I'm silver 2 maybe, but I think I'm 8 and 2 right now. Does the age of the universe change if you take into account time dilation? Yeah, but in our best models of cosmology, there is no time dilation as a result of like the Big Bang or anything. Who is Lemaitre? He was the guy who came up with the first model of the Big Bang. How much do you earn and at what position? So I'm a research doctor. I'm a research fellow at the university that I work at. My salary is around 3,000 euros a month. Or actually, it's a little bit less than that. But I also live in a low cost of living country, so make of that what you will. I'm going to bring up a guest, actually. I haven't had a guest in a while. I'm bringing up a guest from TikTok. Actually, do I have guest slots open on YouTube too? I don't think I do, but I'm going to bring up a guest from TikTok. Let's bring up Ethan. Hey, how's it going? What questions you got for me today? Can you hear me? Yep. So essentially, all you have to do is you have to assume what the universe is made out of. So you can assume that it's made out of dust, you can assume it's made out of radiation, or you can assume that it's made out of cosmological constant. And so that tells you what your stress energy tensor should be. Now, when we say dust, that's just galaxies, right? It's just matter. So the way that matter behaves, the stress energy tensor that you get from matter, the stress energy tensor that you get from radiation, these are all known things. They're easily describable. Well, I'm talking about matter like non-interacting matter that's kind of just sitting there. And so that tells you what your stress energy tensor should be. And from there, you can calculate the curvature. That's essentially it. Well, I mean, so it's only simple because I didn't make you solve the... Oh, wait. Hold on. People can't hear you. Give me an audio check. Oh, sorry. I need to add a audio input capture or audio output capture or audio capture. There we go. I need to add this. Try talking again.
Hello, YouTube. Can you hear me?
Okay, YouTube should be able to hear you now. So the question was... Actually, do you want to just ask your question again?
Yeah. Why did it sound so simple? Where does the hard part come in that made them so famous?
It's not that it's hard per se. You can learn it in a standard GR course. It was just a big deal. Like conceptually, very important to be able to model the entire universe with a fairly straightforward equation.
Oh, okay. Thank you. And I'm going to use the lumpy term because it's fun to say. How much lumpier would our universe have to be for those assumptions to not really hold anymore?
Depends on who you ask. This is a matter of contention, actually. And in fact, this is why that whole business with the timescape cosmology, that was because the authors of that paper think that the universe is already too lumpy for those equations to hold. This is something known as the averaging problem. It's actually, like, generally speaking, when you have a theory, like some sort of field theory that's linear, then averaging works exactly as you would expect it to. Small scale fluctuations do not affect the average much. Large scale fluctuations do affect the average a lot. General relativity is very nonlinear, so it's very hard to say rigorously whether or not small scale fluctuations can add up to large scale deviations from what you might otherwise think. So it's actually a really hard problem. Generally, the consensus is that our universe isn't too lumpy that the assumptions are invalid, that the averaging problem is basically like, yeah, even though it's really nonlinear, it's actually pretty reasonable to think that small scale fluctuations will only affect the average in a small way, and large scale fluctuations will only affect it in a large way. Like, that same intuition is expected to still hold, but it's really hard to prove.
Interesting. I didn't know that was such a point of contention. Well, that was going to be my next question about the timescape. You mentioned a few days ago that you weren't convinced by it. Why not? What's your...
I lean on the averaging works in general relativity camp, and then beyond that, they've only checked it with a single supernova data set. If it comes out that they check it against all of the other available supernova data set, and the DESI results, and the CMB and all of this stuff, and it still checks out, then I'll have to adjust my position.
Geez, I feel like everything is banking on these supernova sets this year. It's going to be...
I mean, that's how we do cosmology, right? Yeah, supernovas true. And baryonic acoustic oscillations, right?
When you say we, that does not include me, but yeah, that makes sense.
Well, I mean we as in humanity.
Yeah.
Doesn't include me either. I don't do data analysis.
So my last question, I know it's kind of beating a dead horse. Is affine time really the only way you can describe a null geodesic, or like a null ray?
Yeah.
Does the paper have any reason to get a formal response?
You mean Kerr's paper?
Yes.
It probably not. It just really. I mean, like, look, people who know about it know about it. People who don't know about it don't know about it. I don't think the paper's getting a whole lot of traction anyway, so it doesn't warrant it. If people started citing it heavily and it started influencing, then it might warrant a formal response. But as it is, I don't think it's getting a whole lot of traction.
Yeah, that makes sense. I mean, he was just sitting in an armchair and chuckling how silly it was. So I guess that put that to rest. Oh, that's all I had today. I'm going to look into it. It's the averaging problem? The averaging problem. It's on my to-do list of videos to make, but I haven't figured out a good way to hook people with it yet. So it's been sitting and collecting dust, but I'll do it eventually. All right, thanks, dude. I'll see you later. All right, take care. All right, I'm going to go back to answering questions from chat, and then I'll bring up another guest in 15 minutes or so. So, bro, it's not just like there's a space-time fabric and mass bends it, so everything else follows its curvature. That can be accepted by anyone decent. Oh, okay, that wasn't for me. Is string theory dead now? No, it's not dead. There's still string theorists still actively doing work. Can heat be negative? So heat's like a process. It goes from point A to point B. So heat being negative would just be like heat flowing in the other direction. In which case, heat flows in all sorts of directions. Why does Musk want to colonize Mars when there's no oxygen? I don't know. I think he probably just heard about it once and he kind of hyperfixated on it. Do you think nuclear fusion will be an applicable source of energy in the near future? I hope so, yeah. What do you think of Oumuamua and Avi Loeb? So, regarding Oumuamua, it was an asteroid. Like, almost certainly it was an asteroid. And that did color my opinion on Avi Loeb, but I hadn't actually read any of his papers, and now I have. And I actually, he's a very, very good physicist. He just writes on kind of exotic or not fringe, but niche things. And he doesn't just do standard cosmology. He has a very interesting brain, and I'd love to work with him at some point. What are your thoughts on time? Sometimes I feel like time is what a clock does. Hey, if the universe is constantly expanding, what's it expanding into? It's not expanding into anything. The universe is everything. But you can just think of the grid as getting further apart. That's all. What's your favorite cosmology theory in terms of what you think is most likely? I'm pretty agnostic. I do lean towards a recollapse. Time travel possible or not? To the future, yes. To the past, no. What is string theory? String theory, it's a model of quantum gravity. It's a model of all fundamental forces, in fact, that posits that instead of having fundamental excitations, like electrons, which are point-like particles, you have fundamental strings that vibrate in different ways, and the way that they vibrate affects the kind of particle that you have. It also includes gravity for complicated reasons. Hey, if the universe... thoughts on Eric Weinstein and new physics? It's a nothing burger. Do you think Planck length and all the Planck units actually describe universal limits, or is it just random things that come from dimensional analysis? I think that it signals that something happens at a certain scale, but I don't think it's a universal limit. I just think it's like a good heuristic for where we should expect quantum gravity. Can quantum physics be coherently reformulated using negative probabilities? I don't even know what a negative probability means, so I suspect not. What is CP violation? So CP violation, CP stands for charge parity. So essentially you have two symmetries, or two classical symmetries anyway, that if you flip all of the charges of all of the particles, you might expect the physics to be the same. And if you flip all of the right-handed things to be left-handed things, because some particles have handedness, in fact, all of the fermions do. If you flip the left-handed ones to be right-handed, you might also expect the physics to be the same. Now, if you just made one of those two changes, it turns out the physics is not the same. Similarly, you might think that if you do both of those at the same time, then you would get, then the physics wouldn't change. Now, it turns out that the physics does change when you flip both of them, but only a tiny, tiny little bit. The other side of this coin, though, is that there's something that's like mathematically proven called CPT symmetry, charge parity time. So if you flip the charges, the parity, and reverse the clocks, then all of the physics remains the same. So the fact that there's violation in charge parity means that there must be a corresponding violation in time symmetry, which gives you an inkling that there's actually something special about the direction that time is flowing in, which is interesting. What do you mean by lumpy? I just mean that the universe has like some empty spots and some places that are less empty. If you had a mile-tall container and pressurized it, would there be higher pressure at the bottom? Yes. How do you measure time with space? Well, you wouldn't. You would use a clock, right? What's the best place in the US for a part-time PhD? Oh, sorry, in the US. I don't know about part-time. Yeah, I don't know. And it depends on what you want to do. What's a graviton? A graviton is a hypothetical particle that, in some sense, would carry the gravitational force in the same way that a photon is that particle that carries the electromagnetic force. What do you think of life in general? I think it's fine. Parallel universe real? I doubt it. Is the universe eternal? You said the other day that you lean towards yes. Yeah, so there are just good philosophical reasons to think that. And also, there's some good quantum mechanics reasons to think that. It also seems simpler than just having an arbitrary start point. So like it's mostly on like philosophical grounds, but there is data that at least allows that possibility. If the universe is expanding, does that mean it is an infinite? No, it can be infinite and still expanding, which seems paradoxical, but the math is fine because the expansion is a local thing. It's like if you look at a given volume, if you put like if you make a cube in space-time out of ping pong balls, and then you just wait, those ping pong balls get further away from each other. Hey, if nothing can escape a gravitational pull of a black hole, how's there Hawking radiation? Hawking radiation doesn't actually come from inside the black hole. It comes from the event horizon and just outside of it. If the universe is everything, does it mean that quantity, matter, and space are infinite? Could be. Yeah, if the universe is infinitely large, yeah. Is reverse magnetism real? Yeah, it's just magnetism in the other direction. Is self-interaction divergence solved in QED, or does it still exist like in classical? So there is still a Landau pull in QED. There's also, there is still a Landau pull, if I remember correctly. Do we need the graviton to understand how and why of gravity? No, classical relativity works. It's just very perplexing that it wouldn't be quantized. Do you think could be any practical use of time dilation? I mean, yeah, it's useful anytime that you have to take into account anytime you're working with super precision clocks that are moving or in different places, right? But practical applications to actually jump forward to the future, not anytime soon. Why do we represent the curvature of space-time only on the plane? Because we can't really imagine much more than that. Does theoretical chemistry still have any merit? I don't know, I don't do it. What do you expect to be inside a black hole? I have no expectations because I have no idea. Please explain MRI. My understanding is that they use magnets to just wiggle the hydrogen atoms, or wiggle the electrons around hydrogen atoms, which are in water. And then those hydrogen atoms, when they de-wiggle, they release radio waves back out. And then we pick up those radio waves and use that to form an image. It's my understanding, but it could be very, very wrong. Where do you get academic news? I don't really. I just read papers as they pop up in the archive. Is there a multiverse? Is the multiverse a viable hypothesis or has it been disqualified? It's viable, yeah. Do physicists use phasors in a polar coordinate system to represent complex numbers? Not very often, no. Do you think the universe will eventually one day cease to exist? I kind of doubt it. Is the universe local or real? I lean towards local. I lean towards locality being a thing. But I mean, you can have both as long as you're willing to give up single measurement outcomes, right? What is the tight binding Hamiltonian for graphene lattice with next nearest neighbor hopping? I don't know. I'm not a condensed matter guy. Why are there so many different notations for spherical coordinates? Well, there's only like 2. Right, r theta and phi and r phi and theta. Why does going at the speed of light decrease time? Well, going quickly to the speed of light decreases time. The simplest way to explain this is that everything traveling through space-time that has mass travels through space-time at a fixed rate. So if you travel faster through space, you travel less fast through time. How far into the future could a single person travel with current limits with technology speed? Oh, you couldn't at all, not with current technology. Reversing magnetism with certain frequencies is conspired to moving ton of block. What? Please, a science fiction book recommendation. Ender's Shadow. What do you think is the hottest physics field right now in terms of job prospects? Oh, there's no jobs. There's no jobs. No, it's probably anything AI related. Probably condensed matter experiment. That's always hot. Can you nutshell why string theory works for some measurements but not others? Well, so we have string theory makes no predictions that we can, no distinct predictions. But string theory does produce all of the, in principle, there is a string theory that will produce the entirety of the standard model, right? The question is can it make novel predictions? Do you think our patch of the universe will eventually undergo false vacuum decay? I hope not, but it could. What do you think of electrical engineering notation? I prefer physicist notation. Is the universe cyclic as Roger Penrose postulated? Conformal cyclic cosmology is almost certainly false, unfortunately. By the way, y'all, remember, like the live. Regardless of where you are, TikTok or YouTube, like the live so we can get more people in here. So more people can get their questions answered. Your thesis was on the 5th dimension, wasn't it? My thesis, so part of my thesis focused on 5-dimensional conformal manifolds. Yeah. It's just a mathematical thing. It's useful from a physics point of view in some cases, but could a spiral universe explain expansion? I don't know what a spiral universe would be. If a wormhole was real, would it emit gravitational waves? Yeah. If it was moving, I guess. What was your daily workload in hours to get where you are? I mean, I never worked myself to death. How do we accurately describe physics with imperfect linguistics? We use mathematics, right? What are your thoughts on creating artificial gravity? I've heard something about using energy like lasers for such things, but I'm not sure. As far as I know, nobody has come up with ways to create artificial gravity. Do antimatters exhibit similar chemical properties to matters? Yes, as far as we can tell. What happens if you run toward a mirror at near light speed and shine a light at it? The light from your perspective will move forward at the speed of light, and from the mirror's perspective, it will also appear to move at the speed of light. Can you prove you're a physicist? Yeah, I mean, I can. Should I just show you my... No, I don't want to show you that. I could show you my PhD if you wanted to, but... Yeah, I'm not going to worry about that right now. What happens if you run toward a mirror? Okay, what is your view on uncaused cause like the Big Bang? I don't think that I don't know if the Big Bang was the beginning. I kind of lean against it. Theo, thank you for the subscription. Do I believe in God? I don't. What came first, the elements or the stars? Hydrogen, helium, and a little bit of lithium came first. And then the stars made the rest. How do we accurately just... Oh, thoughts on quantum immortality? I don't buy it. Can you prove you're a physicist? You kind of just dodge every comment so far. I'm literally not dodging comments. I'm answering questions. But okay. Is it true that the universe is expanding at different speeds depending on where it is observed? Not as far as I know. As far as I know, we still have homogeneity and isotropy, right? Is it technologically possible in the future to achieve light speed travel? Almost certainly not. I could prove it, but actually I can't. I mean, like, look, if you don't want to believe me, you don't have to. That's on you. No skin off my back. Negative time. Yeah, I made a video about the negative time thing. It's not really negative time. All that happened is that the front bit of a pulse came out before the back bit finished going in. That's basically what happened. If the Big Bang wasn't the beginning, then what do you believe? I lean towards like a cycle. But, you know. How do you visualize the Ritchie flow beyond the 2D case? Honestly, I don't. Humans are really bad at visualizing anything that's more than 2 dimensions, especially when you have time. What's your favorite animal? My favorite animal is the platypus. What's the difference between dark energy and dark matter? So dark energy is whatever the explanation will be for why the universe's expansion seems to be accelerating. Dark matter is whatever the explanation will be for why galaxies seem to rotate faster at their edges than we expect, and why we see gravitational lensing in places where we don't expect it. Basically, why there seems to be some type of matter there that we can't see, hence dark matter. Can we concentrate electromagnetic waves to one point and create tunnel of data flow? Yeah, we use fiber optics for that. That's what fiber optic cables are. Is it possible to observe abiogenesis? Yeah, probably. We just haven't done it yet. How to create an atomic bomb? I don't want to be on a list. Is it possible to split the quark and make a new superweapon? As far as we can tell, quarks are fundamental. They don't have internal structure. Can energy be used to create? Can gravity be used to create infinite energy? Nope. How close are we to viable nuclear fusion? I don't know. I'm not in that field. I've heard estimates like 15 years. Do you think the universe is deterministic? In a quantum way, yes. I lean towards the Everett or many worlds interpretation of quantum mechanics, which is deterministic, but there's still many branches. Wouldn't that lead to an infinite regress? Wouldn't there ultimately have to be a beginning? I don't see an issue with infinite regress. There's no mathematical issues. There's no physical issues. Many jobs for physicists and novel medical companies. Yes, there's not many jobs for doing physics, though. Like doing you know, fundamental physics, if you will. Can gravity be used? Oh, I already answered that. It's ignorant to ignore a possible existence of God given empirical limits. Okay. Will humans be stuck in our own solar system forever? I doubt it. Are you a quantum mechanic? I'm not. You blank me, okay, but God, believe it or not, I don't know what that means. So you lean towards a cyclic universe of some kind, yeah. In fact, there's a paper that, or a project that I'm going to be starting soon. I'm waiting on a colleague to finish another project, and we're going to try modeling this like an actual cyclic universe. And see if we can actually get entropy to reverse. Can you explain on how light is both a particle and a wave? Is it possible we are wrong about it? So it's not really a particle. Like there are no real particles. There are just waves that are localized. So you can imagine a wave normally is like really big and it's continuous. But if you just have like something like this and then a whole bunch and then like that, that's a particle. And it turns out that there's a minimum size for these waves. This is like the minimum amount of energy that you can put into a wave. And we call that the quanta, or the quantum of a field, which in the case of a photon, or in the case of light, would be the photon. Do you find medical physics to be a possible future field that has potential to further expand? Probably. It's just not something I'm particularly interested in. Why can't any particular point in an infinite time be our time? It could be. When are you and Abby going to make a long-term YouTube video together? Potentially soon, actually. Not to spoil anything. A cycle from singularity to expansion back to singularity. Well, there would be no actual singularities, but yes, something like that. How do you reconcile diffeomorphism invariance with quantum gravity? That's a hard problem. That is one of the hard problems. How do Goldstone bosons arise when SU2 cross U1 is broken wire there 3? Yeah, so you have, so I'm sure Shaxi, I'm sure, because you're asking this question, I'm sure you know this, but imagine that you just had a U1 symmetry, right? If you break the U1 symmetry, sorry, what's the model that I'm trying to talk about here? I'm trying to talk about the Mexican hat potential. Sombrero potential. It's called that for whatever reason. Essentially, if you have the Goldstone bosons are just the number of degrees of freedom that are unrestricted, that can go around the hat. And then you have, hold on, I might be getting this backwards. Oh, it's been so long since I thought about spontaneous symmetry breaking. I might have to get back to you on that. What I remember is that one of the ways that you can see this is that you have oscillations in one direction, and then oscillations in the other direction around the hat, and one of those is the Goldstone bosons. And I want to say that at least that's one way to see this. One way to see this kind of symmetry breaking. That does apply for the Higgs, by the way, but that's not. I'm not talking about the Higgs. But I'll have to get back to you on this because it's been so long since I've thought about spontaneous symmetry breaking. Is there such a thing as energy that is not contained as momentum? Yeah, sure, mass. Right? Do we live in a deterministic universe? That's the way I lean, yeah. Why do waves not pass through circular slits? They do. Have black holes been confirmed? Yeah, so much. Yeah, so Shaxi, maybe leave a comment on this video and I'll go back and look at it and I'll respond.
What's your background? I got a bachelor's degree. I got 2 bachelors in science, 1 in mathematics, 1 in physics. I got a master's degree in physics, and I got a PhD in physics. Do you find medical physics to be oh, I already answered that. What's the proof that gravity is real? We can do Cavendish type experiments on things as small as like a millimeter-sized ball of gold. Essentially, we can detect the gravitational forces between 2 masses. You lean towards cyclic universe. How do you explain entropy? So, if you have closed time-like curves, then quantum systems on those closed time-like curves can have entropic reversals. This is a conjecture that I have, and I mean it's not original to me. Hawking proved this in some cases. It's been proven in other cases for not the full universe, just for a small loop in a closed time-like curve. And I have a conjecture that it should work for the full universe. And I think that this has even been studied. I just don't have any good references off the top of my head. Have you ever used neutronics modeling software? No, I have not. Is the Earth round or flat? It's obviously round, spherical even. If 2 black holes collide, can they create a new kind of singularity? Not really. Do commercial FM radio signals reach outer space? I don't know. I'd have to go look at their frequency and whether or not that's blocked out by the atmosphere. Are you convinced God does not exist, or just I have high credence that God does not exist. That's my answer. 2 black. Okay, I already answered that. Star Wars fanboy PhD. I do love Star Wars. Or no, I love Star Trek. Star Wars is meh. How long is took to be a physics PhD student? Well, so I did 4 years of undergrad, 2 years for master, 5 years for my PhD. Is time a fundamental aspect of the universe or an emergent property of physical processes? Great question. We don't know what that is. We don't know. Explain how infinite regress works. You said no mathematical problems, but explain in natural language how we could get to this point with infinite past. The assumption is that you're getting to this point from some beginning that was infinitely far away, but there is no beginning. So every moment of time, if every moment of time is equally real, then there will be stuff at every moment of time, and we just happen to be the stuff at this moment in time. Can you explain the many worlds theory? Yeah, I do have a video on it, but the rough idea is that so the analogy is with like electrons. So electrons can be in spin up or they can be in spin down states. Or they can be in a superposition of spin up and spin down. And when that's the case, the spin up part of the electron doesn't interact with the spin down part of the electron. They both just go about their merry way, just doing their thing. And so the idea is that so could the universe. The universe could be an orthogonal, in this case spin up, spin down, those 2 states are orthogonal. The universe could be in many orthogonal states, and in ways that they don't interact with each other. And so hence you have many worlds, where each different orthogonal state corresponds to a world, although it is all in the same place. Where do concepts like the Planck length or time appear? These are just dimensionful quantities that give us a scale where we expect quantum gravitational effects to start. Theoretically, couldn't all matter be split infinite times? No, not as far as we know. So TI, I subscribe to the B theory of time. At least that's the way I lean. Electro weak break, yeah. I should jump down to the bottom on TikTok because I'm a bit behind, sorry. Why doesn't Wheeler-DeWitt solve things? Well, because in Wheeler-DeWitt, you don't have any time evolution at all. So if Wheeler-DeWitt is the correct answer for quantum gravity, which maybe it's not, but if it is, then that would mean that time is really just an emergent thing, right? Thoughts on the Bell rides of 2024? Well, they were less climactic than I would have thought. Can you describe the Landau-Lifshitz pseudotensor and how it really works? I get confused sometimes. I've never had to work with it because I only work with tensors. But my understanding is that my understanding of all these pseudotensors is that essentially, if you have a, what is it? Does it require a killing time vector or a time-like killing vector field? Because I can never remember which one Landau-Lifshitz is. It has a whole bunch of requirements, but essentially all it's doing is it's capturing the gravitational energy by looking at the connection components. The trouble is that if you're you're using the wrong coordinate system, then the connection components are 0. So it's a pseudotensor in that it only works in certain reference frames, right? It only gives you what you want in certain reference frames. In what way is the monster evident in the universe? I don't know what you mean by the monster.
Have you considered talking to Cliff? Yeah, I'd be happy to talk to him. If he wants to talk to me, that'd be great. Hey, if photons have no mass, how can they have momentum? So it turns out that momentum and mass are not intrinsically linked. It's just at low energies, at low speeds, they are. Can you explain B theory of time? Roughly that every moment of time is equally real. It's roughly it. Can you explain how voltage moves electrons? So all a voltage is it's an electrical potential. And electrical potentials between point A and point B produces an electric field. And electric fields are what apply forces to electrons, what apply forces to charged particles in general. And so that electric field is what drives them along. Two ships in space both think they are stationary, the other is moving fast. Which time's slower? So there is no correct answer to that until, so they can if they only meet once, then they might agree, and then they'll just each go on forever thinking that the other one's time is slow. If they meet again, it'll depend on how they met again. Can you explain how the sun's gravity doesn't suck the Earth straight into it? It does, but the Earth's moving too fast, so it falls away. Which mathematics did you find the most difficult and why? Anything that's like algebraic geometry, it's a mess. Will you see complete darkness if you're moving at the speed of light? No, it would be very, very bright. But you can never get there. Never understood how experiments verify hypotheses. If we discovered some string theory before GR, wouldn't we treat string theory as true and not necessarily GR? Yeah, so all you need to verify a hypothesis is that you need your hypothesis to make a prediction of that hypothesis or that prediction to come true. That's all you need. Do you think white holes exist, and what are your reasons for either belief? Probably not. We have no idea of how they might form. We have no way of we've never seen them, and they would be very, very bright. There's just not really good reasons to think that they exist. I am going to bring up another guest. All right, let's bring up Chief. He's been waiting for a while. All right, looks like Chief is not connecting. Let's bring up another. Let's bring up Joe Basta.
Hello.
Joe, how's it going?
Everything is fine, alhamdulillah.
Great. What questions you got for me?
I guess I leaked my faith by coincidence.
Okay.
I'm Muslim, but I fond of physics, fond of math, engineering. I have a master's in electrical engineering.
Okay.
Yeah, so I was writing to you in the comment section a few things. I've been working on Lagrangians and trying to develop solvers for them. And what I found until now is that always when you have a differential equation modeling physical phenomena accurately, you will have non-linearity. So if you're going to solve Lagrangians for unification, like the Feynman unification equation, which if solves, you get unification. If you solve that Lagrangian, unification will happen, but there's a lot of non-linearities. So my idea was...
By the way, I have no idea what Feynman unification is. I've never heard of Feynman
unification.
unification.
Of forces, basically.
Well, are you talking about like grand unified theories? Like guts from like the 80s and 90s?
Yes.
Oh, okay.
Yes.
Sure.
Yeah. So what he did is he put e to the power of all Lagrangians that we deal with, like the gravitational force, electroweak, and...
oh, okay. You're not talking about actual. You're not talking about like some sort of grand unified theory. You're just talking about just throw them all into the Lagrangian, into the Lagrangian and see what happens, right?
Yes.
Okay, sure. What about it?
It's not exactly like that. Well, if you put all the Lagrangians, this is the thing. Lagrangians is like what I would call a Lagrangian is like a modified Pythagorean theory equation. Okay, so what do you modify it for? You might modify it for cost, and then you put your differential operator or the Heisenberg operator, or Schrödinger equation operator, the Heisenberg. Yeah.
Sure. So what's the question?
Yeah. This is the thing. This is the question. Like, if you want to deal with the nonlinearity, I tried something already. All right. So one thing I did is that I made the dimensions nonlinear by scaling it logarithmically.
Scaling
in
what
a certain way,
logarithmically?
right? The dimension itself, like this logarithmic.
Are you talking about like divergences?
Right now, yeah, just write a logarithmic diagram. It's like you log the scale, you log the y
Right.
dimension.
So look, I mean, there are going to be nonlinearities in any quantum in any non-abelian gauge theory. If you have a Lagrangian for a non-abelian gauge theory, you're going to have nonlinearities. Is your question writing down what the equations of motions are, or is your question solving the equations of motion?
Solving. This is the thing.
So you have a question for somebody who studies partial differential equations, then, right?
Well, you're a physicist, theoretical physicist.
Yeah. So there are very, very few known solutions to even classical non-abelian gauge theories.
Okay.
There are some that are known, but they are very, very finicky because they're nonlinear.
All right. So let's say we non-linearized the dimension itself, like wiggle it in a certain way, logarithmically.
That wouldn't really help you at all.
Well, let's try it. Let's see what I did. I took the fundamental equations or functions like polynomials, cosine, sine, trigonometry, other functions that are fundamental in math, and I transformed them to this wiggly kind of space. All right. So, and then you transform the whole equation that you have. For example, electromagnetism differential equations, which are the Maxwell equations. You put them there. They will look like different, but you will know that this element coming from that element from the Cartesian coordinates. So then, what will happen is that because it's because I altered the dimension with the trigonometric alternation, all the trigonometric terms in the Cartesian will look algebraic, will look polynomial.
So wait, to be clear, what's the question here?
The question is what I'm doing correct.
No, it's not. And the reason why we know it's not correct is because the Lagrangians are covariantly or are diffeomorphism invariant. So it doesn't matter what set of coordinates and how you rescale the coordinates. It does not matter at all. It doesn't affect the differential equation. Now, it might be the case that one particular set of coordinates might make solving the differential equation easier, but it doesn't change the differential equation at all. You're not doing anything physically meaningful. All you're doing is rewriting it in a different set of coordinates.
Yes, you write it in a certain set of coordinates, but the thing is, if you play carefully with the coordinates, many terms will cancel out. Like that.
Well, that's called just doing a good gauge choice, and that's one of the ways that we study partial differential equations. You have to make a good gauge choice.
Yeah. So until now, I worked on the logarithmic part. It shows polynomial on the transformed side, and I worked on the trigonometric parts of any kind of equation. And it will show also as a polynomial. So a combination of those two will show as a polynomial. Like you have an equation that is like, for example, let's say cosine of log x squared plus x.
So look. So I understand that this is what you're trying, but it doesn't seem like you have another. It doesn't seem like you have another question, right?
Well, here's the thing. What I found, I want to ask you about what I found, and you can tell me if it is fitting. What I found, first of all, is that the duet that you mentioned, for example, will point at, if you take it to the quantum scale, it will point at quantization of time regarding like backwards and forward. It will have an oscillation, first of all. Second of all, you will see that, what they call it? You will see that the solution shows that at some certain level, if you keep applying the solver.
And which equation? Which equation is the solution?
It's like time will have a.
Like, no. What equation are you solving?
In that case, the duet invariant.
The Wheeler-DeWitt equation.
Yeah. Yes. It shows like timeless solution. Like it doesn't have a time variable, and if you manipulate it a bit, it will show you the entanglement is what is below everything. Here's the question: what is getting entangled there? It doesn't explain it. Like, okay, it shows that mass, or space-time or any other fundamental constant or variable is emergent.
So maybe that's the case. I have a hard time believing that you found a general solution to the Wheeler-DeWitt equations because there generally are no solutions. No general solutions to nonlinear differential equations, nonlinear partial differential equations, and this is very nonlinear.
Well, you can see from the traits of what the equation that resulted. I'm not sure if it's correct or not. What the traits are. Time can have an oscillation. Like a particle could come from the past, and like a small period, like small delta of time, can come from the past or the future. Causality is very different. Like something from the future could affect the current time.
So Joe, I'm going to cut you off because now you're just telling me about your work instead of asking a question. But thanks for being here.
All right.
Is Jason Padgett theories true? No. No, they're not. Unfortunately, they are not. I only want to know if I can travel to another universe where Trump lost. No, you cannot. You get paid good? Decently. Do you know what time we're at in human precipice? I don't know what that question means. What's your focus in differential geometry? I do conformal geometry. Specifically, I do what physicists would call holography. I do extrinsic geometry in particular. Although I've been branching out, I do more stuff than that. I mean, like I recently wrote a paper that got published in a very good physics journal on quantum gravity and some like non-commutative geometry. So that was fun. Can you explain root mean squared speed? Yeah, so velocity is a vector, it has a direction and a magnitude, so you can't just take the average. If it's evenly distributed, your average would be 0. So instead, square it to get the lengths, take the average of that, and then take the square root. And that won't give you 0. That'll basically give you, in some sense, a measure of how big the speed is on average. Why do photons have momentum? Because the electromagnetic field must have momentum in order to conserve momentum. So you can imagine that if you have an electron traveling through an electric field, an electromagnetic field, its momentum will change. So if you want momentum to be conserved, you have to assign momentum to the electromagnetic field. And a photon is just an excitation in an electromagnetic field, right? And indeed, you can calculate with the behavior of the electromagnetic field. You can actually derive this from first principles rather than just asserting that it must be true. Can you explain spacetime in terms of 4D instead of the common 2D way? Well, no, not really, because we can't visualize it. But it is just four-dimensional. Geometry proves Jesus because the cross has 4 points. Okay. What are your thoughts on spacetime being non-commutative and thus not being a manifold? I think it's an interesting thought. I'm not sure if I believe it, but it's certainly an interesting thought. Is it okay to ask you non-physics questions? Yeah, sure. Are you in the physics server? I don't know about any physics server. Are you going to bring up any? I already answered that, Alice. Yeah, I'll bring up another guest, just not yet. I'm gonna answer some more questions for a bit. What is our best understanding of dark matter? Pretty much still in the dark. Can log function be extended to output and input complex numbers? Yes. What were the recent discovery of new types of quantum particles like fractional excitons? I don't know what you're referring to. What's your favorite kind of bread? I like dark bread. One more question, sorry, but when the Goldstone bosons are absorbed by W and Z, how do they become states of longitudinal polarization? I don't understand it fully. So, again, not my area. I haven't done like actual symmetry breaking in a long time, but my understanding is that this is the kind of thing where basically you can kind of lump in their 1 degree of freedom to the 2 degrees of freedom that the W and Z's have, and it works together in a natural way just because of the equations of motion that both the W, or just because the way that the W's and Z's and the way that the Goldstone bosons appear in the Lagrangian, they kind of slot in naturally to fill the that role. Favorite band? Thank you for the $5, Nectu. By the way, if you guys want to support me, you can. There's super chats on YouTube. There's also a Cash App or a Buy Me a Coffee link in my bio, either on YouTube or in the Discord. Ethan bought me 3 coffees for $15. Thank you, Ethan. My favorite band is, right now I've been listening to a lot of Ghost, but my favorite band is probably Beast in Black. And the video game that I'm playing right now is Marvel Rivals. Heard physicists no longer believe the Big Bang is the beginning of the universe. I don't know what it's certainly not the consensus like it used to be 40 years ago. Maybe it's something between a small minority and a large majority is probably taking that position. But we don't have any any data on that because just nobody's done any polls. What's the biggest discovery of the 21st century? In my view, it was gravitational waves. I'm considering going for graduate school, master's, maybe PhD. How do I know if it's right for you? You'll know during your master's degree if it's something that you'll like. So I would go do the master's, because the master's will certainly help you get a job. Like, getting a master's degree in physics is nothing to sneeze at. And if you are sick of it by the end, then just drop out and master out. How does quantum geometry influence Berry phase in non-abelian gauge theories? I've read a paper on this a while ago, but I haven't actually thought about it a whole lot. I think somebody was proposing an experiment that it might be able to detect, like, essentially quantum gravity effects. But I haven't looked into the details at all. Would it be physically possible for a planet to be shaped into a letter number? Probably not. Has there been any new research to support the Big Crunch theory? We're waiting for new data to come out in March, which may or may not support it. What's the most unorthodox or out there position you hold in physics? Well, the majority doesn't accept the many worlds interpretation, and I like that. So I don't know. That's not super unorthodox though. What is dark energy? Dark energy is the explanation, whatever it may be, for why our universe's expansion seems to be accelerating. Yeah. So to be clear, you should apply for a physics PhD program, because then they'll fund you. If you just do a master's program, they will not fund you. So apply for the physics PhD, and then you can master's out if you decide it's not for you. Is 0 technically a number? Yeah, it is. Would you want a platypus for a pet? If it loved me, yeah. Do you know anything about beta voltaic cells? I've heard about them. I don't know anything about them, but they seem really cool. Some particles travel faster than the speed of light theoretically. So my question is, when were they created during Big Bang or Big Crunch? So we don't have any reason to think that they exist. The particles that travel faster than light, they're called tachyons. We don't think that they exist. When I say we, I mean basically every physicist. Why do you support many worlds? It is the most simple model mathematically. How long are you going to rationalize string theory? String theory is useful because of the mathematics that helps us develop, and because of the insights into quantum gravity that we get. Even if it doesn't apply to our universe, it still is a consistent theory of quantum gravity, which will give us some serious insights. Like, that's how we got holography. We got holography from string theory. Are physicists usually liberal or conservative? Liberal, but that's just true of all academics. How does curvature of quantum state affect topological invariance? That's a good question that I'm not equipped to answer. I haven't done a whole lot of quantum gravity stuff, period. Yeah, I'd have to actually think about that in details, but I'm not equipped to answer that. I'm almost strictly a classical relativity guy. What is your area of research? Relativity and differential geometry. Who do you like to play in Marvel Rivals? I like to play Magic. I like to play Black Widow and Hela. I like to play Groot. I like to play Rocket. I like to play Mantis. I like to play Namor or Namor. Do you have pets? I have a cat. How does photosynthesis occur at room temperature within the plant, since it's not possible for scientists to do it? I don't know. I haven't thought about it a lot. Photosynthesis, I believe, uses some quantum stuff, but I don't know how quantum-y it is. Do you know the reason why I suddenly like you so much is because you're so crisp with your answers and really knowledgeable? Well, I appreciate that, Interneil. How to argue with flat earther who calls everything CGI? Tell them to do their own experiments. I do, Interneil, and I do appreciate you. Currently doing physics in uni. Any tips? Go to office hours. Seriously. It'll be the best thing that you can do. What rank are you in Rivals? So I only have played 9 ranked games. Maybe 10. I'm currently silver 2, I think. And I think I'm 8 and 2 or 7 and 3 or something, win-loss. What's holography? Holography is this idea that you can describe a gravitational theory in terms of one fewer, like a gravitational theory in, say, 4 dimensions, in terms of a non-gravitational theory in 3 dimensions. Can you explain the difference between Hubble's constant and the cosmological constant? So Hubble's constant is just a number that relates the distance to the speed. The cosmological constant is what causes the Hubble's constant to change over time, essentially. You should stream your gameplay? Maybe. What is relativity? Relativity is the shorthand for special or general relativity. General relativity is this idea that space-time warps, and that's the cause of gravity. Who is your favorite physicist? Living, probably Roger Penrose. Dead, probably Albert Einstein.
Any other favorite video games? I played Overwatch for a long time. I played Baldur's Gate. Baldur's Gate was excellent. Kerbal Space Program's in my top 5 of all time, probably. Same with Factorio. How does space-time curvature constrain local inertial frames in GR? I don't know what you mean by constrain. So what it does mean is that given if you have a non-homogeneous space-time, then there might not be a single frame that is inertial at every point, meaning that that the Christoffel symbols don't vanish everywhere. But you can still have you can still find the Christoffels vanishing at one point always, whether or not there's space-time curvature. What does quantum mean? Quantum just means, it's kind of a catch-all term for like small-scale effects that behave non-classically, like they don't obey the normal Newton's laws, and they behave in like this kind of quantum way. Are you a fan of Griffith's introduction to E&M? Absolutely. Why don't butterfly effect apply in a normal world where there are infinite number of errors in the real? They do. They absolutely do. What is a rough comparison between collision of proton and free I don't know what that means. How does the concept of a multiverse challenge the foundations of cosmology and quantum mechanics? Andromeda, you always ask the big questions. I don't think it really challenges the foundations. And it depends on what kind of multiverse that you're referring to. But generally, multiverses are pretty tame, as long as you're referring to the right kind. What was the greatest duel in history between one or more mathematicians or physicists? It's got to be the Einstein-Bohr debates. Like, those are just the most famous. But, importantly, Évariste Galois actually died in a duel. So, he was a very, very important mathematician. I can reach the end of time in a singularity if the mass is infinite. I don't see how those two things are fighting against each other. How often do you publish research? In 2024, I at least submitted 5 academic articles. 2025 will probably be, well, it might be similar if I get a job, if I get rehired somewhere else. We'll see though. Do you think that humans will ever be able to time travel? Only to the future and only very slowly. Is there anything that we've observed that goes against our understanding of math or physics? Not math. Physics, though, sure, yeah, there's stuff that we can't explain. Like dark energy. Who knows? We have no idea what that is. Where do Feynman diagrams occur other than annihilation? This right here is a Feynman diagram. This is just a type of electron scattering. Does that mean Lorentz invariant constant isn't constant in general? So in general relativity, we have local Lorentz invariance. We don't have global Lorentz invariance anymore. Is it true that the Earth's magnetic field has shifted? Yeah, so Évariste Galois died because of a duel over a woman. He was like 22 or something like that. He isn't reading the chat. I'm reading sus. Sure, I sure am. I'm just a little bit behind. What is time in relation to space? Time is just, it's like negative, think of it as like negative space. That's kind of one way to put it. If you put enough energy into a Planck unit, they say it would create a black hole. Is the opposite true, that if you extract all the energy out of a Planck unit, a white hole is created? You can't really go lower than the 0-point energy, so you can't really remove energy lower than that. Are most PhD programs created equal? No. Really, there are different quality PhD programs. Do you think it is possible to build a warp drive in the future? I suspect not, but I'd be happy to be wrong. Can you explain electrodynamics in like 2 sentences? Yeah, so there's 2 things going on. First is that charges move in the direction of electric fields and they swirl around magnetic fields. And changing electric fields cause magnetic fields, and changing magnetic fields cause electric fields. Also, charges create magnetic and electric fields. That's 3 sentences, but, you know, is there a beginning of time at the Big Bang, or do we have any idea whether there was time before? We just don't know. We just don't know. What did you do your PhD in? I did it in conformal geometry with applications to holography. Why do you need a PhD in a job to release papers? Well, look, you don't need a PhD to release papers. I had 1 publication as an undergrad. I do need a job because if my job isn't doing physics, I will need a job doing something else, which would mean less time to do publications, right? Less time to actually do research.
Is the many worlds interpretation probabilistic or deterministic? It is deterministic insofar as the entire wave function is concerned. Blitz, thoughts on proposals for research grants and student aid to be cut? I think it's terrible. I think it's awful. Do you think we should bring dueling back? Well, I wouldn't be good at it, but maybe. I don't know. How does the concept of quark-antiquark pairs explain the structure of mesons? Well, that's what a meson is. A meson is a quark paired with a different kind of antiquark, right? Time is relative. How do we trust what we know about light speed distances? Oh, well, there's kind of like a cosmological reference frame that we can use because the universe does seem to have a preferred frame of reference, namely the frame of reference where the cosmic microwave background radiation is isotropic. So we can just use that. That's basically what we do. But for the most part, most things are not moving that much relative to that, so it's not really going to change. Have you ever failed a subject? I once withdrew from a topology class when I was a freshman in undergrad because I was not equipped to take the topology class. I think I got like a D- on the first midterm and I dropped it after that. I just dropped the course. How much theoretical math did your undergrad have versus something like comp sci? Probably way more because I did a bachelor's degree in mathematics. So why is he ignoring me? I'm not. I'm just reading questions from both TikTok and YouTube. Do fish defy gravity? No, they swim. Why are you researching in relativity when 100 years ago Bohr challenged Einstein? Bohr didn't challenge relativity. Einstein challenged quantum mechanics. What do you mean by dueling? Can you explain it? The thing where you stand back to back, you take paces, and then you fire at each other. that thing. Can flies see infrared in space? I have no idea. I don't know anything about flies. Are you a researcher or a professor? So I'm a postdoc. So I'm faculty at a university. My job description is like researcher 2. I don't have any teaching obligations though. So my obligation is solely research. Why does spin affect the flight path of a ball? Oh, because it can entrain the air around it in funny ways. Can gravity be negatively charged? As far as we know, no. If you were offered a professor position without research, would you accept it? Probably not. I already have essentially an offer for that. Kind of like a standing offer for that. If the universe is constantly expanding, do you think we would ever be able to actually reach... Presumably you mean the edge. There is no edge of the universe. Almost certainly. How can divergence in fluid mechanics be applied to general relativity like in black holes, maybe through trajectory? I don't know what that question means. Do you see a space for mathematicians in physics research group, or it's more like physicists with extra math education? There are mathematicians who do physics research, like there are proper mathematicians who started doing work in physics. There are proper physicists who started doing work in mathematics. There's a lot of overlap. Why can't humans see other types of light, and would it be useful if we somehow could? I mean, the reason why is probably evolution. Essentially, we have certain kinds of cells in our eyes that detect light in a very specific band of frequencies. And those happen to be useful, so we didn't need to see anything else. Would it be useful if we could see others? It'd be neat. I don't know how useful it would be, though. Is there a frame of reference where the universe is 6,000 years old? I guess probably, but it's not a preferred reference frame. Why do you host these ask sessions? I see it as a kind of outreach. It's a good way of, exposing people to what physics is like, right? Any advice for undergrads who didn't have traditional start to physics? Go to office hours. That's the advice I will always give if you're asking for advice, because it's so invaluable. You have somebody who has spent their entire life in a field at your service for an hour every week. Go to them, ask questions. That's what these are. Can scientists be engineers and vice versa? Sure, but scientists by default are not engineers. Sorry, engineers by default are not engineers. No, engineers by default are not scientists. Scientists by default are not engineers, but they can cross over, absolutely. Do all massless particles travel at the speed of light? Yes, basically yes. However, that's assuming that they're traveling through a vacuum. If they're traveling through a medium, then all bets are off. They're not even really massless anymore. They're not even really like well-defined particles. Was just talking about you in a live earlier. You got props for scientific honesty and accuracy. Oh, wait, who was?
Would you come to Mexico if you were offered a permanent position at a university? Maybe, but I didn't apply anywhere there. Can people who are not in school or studying anything go to office hours? I would check with the university, but probably. Just show up. What are they going to do? Your professor doesn't know all of your faces, right? Any advice for... Can gravity have gravity? Yep, it does. My daughter is going to pursue a degree in physics. What advice can you give her career-wise? It depends what she wants to do. Like, if she wants to do physics for her whole life, the most efficient way to do that is to become an academic. But the odds, like, for any given person who gets an undergraduate degree in physics, I think that, like, 2% or something like that actually end up going on to become academics. Like, professionally, professors at a university. It's just very, very, there's a very, very fine filter. Are you European? No, I'm not. I'm American. Was just talking about Unilive earlier. You got props for us. Well, I appreciate that. Yeah, this is just a TikTok office hours. I might do these more frequently depending on whether or not I get a job, but we'll see. What's your favorite space movie? Interstellar's good. It's a good science movie. What if gravity was negatively charged? Would it be hard to detect? I don't know what you mean by charged. Is there still much need for physicists in fusion development, or is that mostly an engineering field? No, there's still a lot of need for physicists. Is it possible for something to travel fast in the speed of light? Not that we... Probably not, but there are some models that allow for it. Of course, Ivy. Ivy, your stuff is so good. It's just like... I can't watch it while I'm scrolling in bed next to my wife. By the way, if you haven't yet, go follow Ivy Doll. She makes amazing physics content, science content in general. Just make sure that you're watching in a safe place. Do you know about plasmic consciousness? I don't really know. Well, look, so the reason why Mexico would probably be okay is because it's very, very close to home. And also, Babs speaks Spanish. So she'd probably be fine there. Is it possible for something to try? Okay, I already answered that. If an adult has never understood math, how should they learn it? That's a really good question. I don't know. I'm not an expert in pedagogy, so I would have a really hard time doing that, especially for people that are, like, I haven't interacted with people who are, like, at that low of a level, like, need that much foundational work, ever, like, as a teacher. Like, I've worked with students who are, like, you know, at the level of, like, familiarity with algebra, but struggle with calculus. Like, I've worked with that, but I just don't have any experience with it, so it'd be hard. Sorry, Alice. Have a good one, though. By negatively charged gravity, I think it means repulsive gravity. Yeah, I think so, too. Did you do pure or applied math for undergrad? I did a pure math, and I also did physics. Can you tell us more about the eternal universe thing? What's consensus? There just isn't a consensus on this. Why is the Earth spinning slowing down? The Earth spinning is slowing down because the moon, actually. The moon is pulling on it. Is time considered quantized in quantum mechanics? No. From the POV of a particle falling into a black hole, will the black hole evaporate before it reaches the singularity? No, it reaches the singularity in finite time. What's your favorite color? I like green. Would you work for Lockheed Martin? No. We don't see lower... Oh, okay, I already answered that. Would it be hard to detect something pushing stuff away? Would it be hard to detect something pushing stuff away instead of pulling it in by gravity? No, we could detect that. We just don't. Can you explain the axis of evil in physics? It actually seems like the axis of evil has been debunked as of a few years ago, but this idea was that if you look at the cosmic microwave background radiation and you filter it in just the right way, it actually looks like there's a preferred direction that kind of aligns with the solar system's ecliptic, which would be very, very weird and very, very unlikely. But I'm not sure if it's actually believed to be a thing anymore. It may have just been like a statistical fluke. Can you tell us more about the eternal universe thing? What's consensus? What's new? And your thoughts? There just is no consensus. It's the wild, wild west. What's your favorite pure math class you took at uni? I really like number theory just because my professor was excellent. How would traveling forward in time work? You're doing it right now.
Can you explain the growing block universe? Roughly, the idea is that you have a block, like imagine a loaf of bread, where the front half is missing. The back half is the past, and then every new moment adds a new slice. That's the idea. What are your thoughts on the necessity of humanities while studying physics? A lot of my peers complain about them being useless. I think that humanities are useful to be a well-rounded person, but as far as physics is concerned, it's not necessary, right? Can you explain CPT symmetry? Yeah, C, charge, P, parity, T, time. So if you flip the charge on all of the particles, if you swap left-handed for right-handed and vice versa on all of the particles, and you reverse all of the clocks, then none of the physics changes. How did you get into physics? I was like 9 years old or something like that, and I saw a picture of a black hole, and it was really cool. That's literally the origin story, right? Hey, Haley. Nice to see you here. What kind of physics do you do? I do relativity, lots of relativity stuff, but very theoretical relativity, like mathematical relativity, not like experimental relativity or observational relativity. And then I do differential geometry, which is the branch of mathematics that relativity uses. 3 reference texts you can't do without. Let me pull up my books, and I'll just, because I have a lot of books that I like. So the question is which ones do I like the most? So I use Spivak a lot. Like Spivak's differential geometry book is amazing. I also reference Gravitation by Misner, Thorpe, and Wheeler a lot. I use that one quite frequently. Those are probably the 2 ones that I use the most frequently. Yeah, I wouldn't say that there's 3 that I couldn't live without. Can you give the best case for the eternal universe and explain B theory of time? So B theory of time is just like you have a loaf of bread that goes on forever in each direction, and then each slice of bread is a moment in time. That's the B theory, basically. And the best case for the eternal universe is just that. It's just a loaf of bread that goes on forever in both directions. Maybe you have re-expansions and re-collapses over and over again in a cycle. Would the Big Crunch violate one of the laws of thermodynamics? Not necessarily. Who did you say to follow? Their name is Ivy Doll. I don't actually know if she's on YouTube. Would you ever read the CRC reference book for fun? No. Have you seen The Big Bang Theory? Yes. How is the James Webb effect in cosmology? It's giving us a lot more information. How accurate was the science in it? It was all right. How are you? I'm doing okay. Without humanities, how could you grow your creativity for exploration of new things? So the thing is there's a lot of creativity in physics. Like, physics is a creative field. And I do think that the humanities are valuable, but just strictly speaking, you don't need them. You don't need Shakespeare in order to study physics, right? Is time fundamentally discrete or continuous in the context of quantum gravity? Depends on which quantum gravity you're doing. What math software do you use the most? I prefer Maple, but a few months ago, my Maple license got revoked, essentially. So I haven't been able to use it. So I've been kind of screwed for a while. What are left-handed and right-handed particles? Essentially, they tell you what the particle is doing, which way it's spinning as it's moving. Where did you get your education? At a university in the US. Can you explain something I heard Ryan Green say about if all of space is out there, then all of time is out there too? Oh, that's a nice way of saying it. Yeah, so space and time are on equal footing, essentially. That's what we learned from general relativity. And so if you think that all of the space exists, why wouldn't you think that all of the time exists? How many books do you think you read a year? Oh, like 0, or maybe 1. I don't read very much. I use textbooks a lot, and I read papers a lot. I just don't read books. What's our current understanding of the universe geometry? Are we in a Euclidean or Riemannian? Our universe is described by Lorentzian geometry, which is kind of just an offshoot of Riemannian geometry. Do you think the Janabekov effect, also known as the tennis racket theorem, also affects planets? Planets are pretty spherical, so not really. Who's your favorite physicist slash mathematician? It's got to be Einstein. What does the weak force violate CP symmetry? I don't know what that question means. Why does it? How does it? It just does. Like the weak force moderates some decays, for example, and some decays are preferred in one direction or in one charge than the other. Why do you think you repeatedly can't get the job? Oh, well, it's not repeatedly. I applied to a bunch of jobs, and if I'm going to get a job, I should hear back this month, basically. So, I mean, who knows? Maybe I'll come back tomorrow and be like, they offered me a job. Like, it's this, like, it's the very end of January is when offers start going out, and they'll be going out throughout the entirety of February generally. So who knows? Do you have one huge goal you're passionate to achieve? Not really, no. What's the issue with the BGV theorem? It's just I'd have to go read the paper again. But so I'll just send you a link, or I'll quote the paper title and then you can read it. I read it like a year ago, or maybe not a year ago, maybe less than a year ago. But it was just fairly involved, and it was a fairly small hole. But it's an important hole that needs to be thought about. So let me pull up the paper. It's actually by a former professor of mine. I believe it's by a former professor of mine. It's called On the Past Completeness of Inflationary Spacetimes. That's what the paper's called. So go read it. They mentioned the BGB theorem, and they mentioned that there's a hole. Can you explain entropy? Entropy is, roughly speaking, a measure of disorder. It's not exactly that, but it's quite close. Thank you for entertaining all these questions. Of course. How is the job climate for an astrophysicist, and is it better to be an aerospace engineer? It's always better to be an engineer because companies will hire you rather than just universities. But the job climate for an astrophysicist is probably a little bit better than it is for a general physicist or like a theoretical physicist right now. What's the plan if no offer by March? Who knows? Maybe I'd just be sad. Maybe I go teach for a year. Maybe I try doing content creation full time. It'd be a real bummer. I try not to think about it because it gives me panic attacks. So let's not. Can you debunk flat Earth as fast as you can? Sunsets. Yeah, sunsets. There you go. How does time dilation work? I haven't gotten a feasible explanation. So one of the ways to explain it is that everything travels through space-time at the same rate. But the faster you travel through space, the slower you travel through time. Do you think there are more wheels or doors on the planet? Depends on what you consider wheels and what you consider wheels and what you consider doors. Can you explain Noether's theorem? Which one? If you're referring to the first one, the first Noether's theorem is the statement that if you have a Lagrangian that is invariant under a variation with respect to some symmetry, some continuous symmetry, then there's an associated conserved quantity to that symmetry. So in particular, if you have a Lagrangian that's invariant under time translation, then you get energy conservation. Spatial translation, you get momentum conservation. Rotation, you get angular momentum conservation. Why lambda CDM over Mond? Because Mond can't explain anything except galaxy rotation curves. Favorite physics demonstration? I like the thing that ice skaters do, where you're spinning on a chair, you pull your arms in, and you spin faster. That's always fun. If all time is out there, then does that mean all future events too? Yep. Yes, it does. Yes, it does. Which scientist do you glaze the most? Albert Einstein. Easily Albert Einstein. Quantum mechanics shows that nature is random or that our models can't be deterministic. Not necessarily. If you accept the Everett interpretations of quantum mechanics, then it is entirely deterministic. We just aren't able to use that deterministic nature of reality to figure out which universe we find ourselves in. Can you give a breakdown on quarks, or is that more quantum? So quarks are quantum objects. They are the fundamental constituents of matter, as Hank Green once said. There's a great song by Hank Green from like 10 years ago, or maybe even more, that you should check out. It's called Strange Charm, or something like that, which you should go watch on YouTube. Opinion of Nikola Tesla? Brilliant engineer, brilliant inventor, not a scientist. Why does relativistic momentum only base off of one observer and its Lorentz factor seems different? Momentum is only... so generally speaking, energy and momentum are not... they're not Lorentz invariant quantities, right? They're just not. So the energy of a thing or the momentum of a thing can be different for different viewers. I should have said inventor, not engineer, because he wasn't really an engineer either. The true test of intelligence is if you get what you want out of life. Is that what? That's weird. Have you heard of the semi-direct fermion that is massless in one direction but massive in another? I've heard about it. I haven't looked into it at all. What do you think of Albert Einstein dismissing quantum theory because of his religious beliefs God does not play? He didn't dismiss quantum theory. He dismissed the particular interpretation of quantum theory. Can you explain what happened during the Big Bang? How long ago was it? So the universe, 13.8 billion years ago, the universe was very, very small. The observable universe, anyway, was very, very small. And then it began to expand. Would you rather fight 100 duck-sized horses or 1 horse-sized duck? 100 duck-sized horses, easily. What was the first thing that got you really interested in physics? It was black holes. So if the black hole singularity is like flying in space at 99% the speed of light, yeah, sorta. Don't you think that many worlds is way far from parsimony as it's more a mathematical? No. So when we talk about theoretical parsimony, like in a theoretical model, we talk about the parsimony of the governing equations. We don't talk about the implications. The implications are what the implications are. We talk about the parsimony of like the actual assumptions going into it. So the only assumption going into many worlds is that we take the Schrodinger equation at face value. That's the only assumption that goes into it. Every other interpretation has extra stuff added on. Bohmian mechanics, you have another equation that describes the motion of the particle. If you have the Copenhagen interpretation, you have that everything obeys the Schrodinger equation until you interact with it, and then it collapses for some magical reason. Like, the many worlds is really the most parsimonious theoretical model that we have. Which interpretation did Einstein dismiss? The Copenhagen interpretation. Hydrate? I'm out of water. I need to go refill my water, but I might just end the live before I do that. Are you recording these lives? Yes, they're currently also live on YouTube, and so these live streams will be available on YouTube as well. If you could be any type of soup, which one would you be and why? I'd be garlic soup. What's the most undeniable evidence we have to disprove young Earth? Need to know. Zircon crystals. It's a type of zirconium-based. It's a zirconium oxide, I think. It's zirconium silicon dioxide or something like that. Anyway, zirconium crystals can trap uranium, but they can't trap lead. So if you go find a zircon crystal with lead in it, then that lead must have come from uranium decaying to it. And you can figure out how long ago that zircon crystal formed. And this is the best way to figure out that the Earth is 4.5 billion years old. Given that string theory is a consistent theory of quantum gravity, how does it deal with black hole singularities? Does it even need to? It's not clear. People have looked into this, but it's really, really hard. Nektu, thank you. I appreciate you. It's really, really hard to actually do string theory to like in physical situations. But some people have posited that you get like a fuzzball. Or like, I think they call it a fuzzball. It's like a stringy ball at the core rather than an actual singularity. How light can bounce 180 degrees from a mirror while keeping its speed constant? Theory? So the actual interactions of light bouncing is there's like essentially, yeah, there's a whole bunch of different ways you can describe it. One way you can describe it is absorption and simultaneous re-emission. But essentially, it's just not a particle with mass, so like it doesn't take time to accelerate. How come zircon cannot integrate lead? It's just not. So essentially, in the zircon crystals, the uranium can take the spot of a zirconium atom, but just because of the atomic structure of uranium versus lead, it just the lead atom just doesn't fit into the same spot. How did you become a physicist? Well, I got a PhD in physics, and now I do research as a physicist/mathematician. How do mirrors work? Magic. Griffiths for electromagnetism any good? Very much so. Which book would you recommend to a proper beginner with physics? A Brief History of Time by Stephen Hawking. Know of any other shows similar to PBS Spacetime? No. PBS Space, or actually, so Dr. Becky Smethurst, she's good. Not the same as PBS Spacetime, but she's very, very good. Veritasium is similar, but doesn't cover the same type of topics. But yeah, basically, PBS Spacetime is the premier, in my opinion, the premier kind of fundamental physics YouTube channel. It is the YouTube channel for fundamental physics. Good luck on your stat physics exam, bro. What's the next step in learning about particle physics for an at-home beginner? Pick up The Theoretical Minimum, or alternatively, The Biggest Ideas in the Universe by Sean Carroll. What the fuck is garlic soup? It's a Czech soup, and it's very delicious. If you fly 99% the speed of light round trip, do you come back 98%? Why? I don't know what that question means. Could experiments fall apart due to observation because of photons hitting them? Yeah, it's sort of. What is gravity and what are gravity waves? So gravity, as far as we can tell, is a disturbance in space-time. So gravity, as far as I can tell, is a curvature of space-time, and gravitational waves are disturbances in space-time that propagate. Are these live streams on a schedule? Yes. So Ask a Physicist is every Wednesday at around 7:30 Central European time, which is 1:30 p.m. Eastern Standard Time. Sometimes a little bit later. How does topology work? Bro, I'm not a topologist. Do you like Professor Dave's content? Generally, yes. It's just not very physicsy. In the Big Bang, where did the first particles come from? This is called baryogenesis. That's the search term, baryogenesis. And so this is essentially you have a whole bunch of energy, and for reasons that we don't fully understand, it's dumped into the fundamental fields that we know of, like the quark field and the electromagnetic field and the electron field and all these other fields. And that basically shoves a bunch of energy in, which splits off into particles and their antiparticles, essentially. What's your expert field? Differential geometry and general relativity. Is the multi-guest box open? Probably not. I'm ending the live shortly. How long have you been doing physics? Well, I started my undergraduate degree 13 years ago. Check, you mentioned no way. I live here. Is there any reason to suspect that quantum gravity could violate CPT symmetry? Probably not, as long as you have, well, actually, yes. If you violate Lorentz symmetry, if you violate Lorentz, like local Lorentz invariance, then yeah, you could violate CPT. Because I'm pretty sure CPT requires just unitarity and Lorentz invariance. It splits, everything is very well scheduled. I do my best. Can you talk about the Bekenstein bound? I actually have a video on that. I don't know if it's on YouTube yet. It's definitely on TikTok. But I'm actually gonna I'm actually gonna end the live because I'm very sore throat. So I'm gonna end the live. But thank you guys for being here. And if you're watching, make sure to follow on YouTube or subscribe on YouTube if you're watching there. Make sure to follow on TikTok if you're watching there. And if you want to join my Discord, there is a Discord link in both the description of the YouTube video and in the link tree in my bio on TikTok. So go join. You can ask me questions there. I'm always around. I mean, I work from home most days, so I can answer Discord questions, and there's a bunch of lovely people there that can also help. So if you want more questions answered, make sure to go there, and I'll see you guys next time. All right, let's end this live.